All right, class, this is a video on conversion problems from Chapter 1 for my Chemistry 140 General Introductory Chemistry. And I just want to do there are plenty of videos there on conversion problems on Professor Chemistry in YouTube. And you know that because if you're hearing this video, you probably have been there. So I think the problem that needs to be discussed, though, that probably wasn't discussed in the other videos, is exactly how do you convert using your calculator. So let's walk through a few problems, and also I want to talk about what you need to memorize and what you don't need to memorize. What I expect for memorization in Chapter 1 is that you can convert any metric to metric unit. So if someone says, I have 5 micrograms, and I would like to know how many kilograms that is, that you could do that conversion from memory. And the way this works is that microgram equals 10 to the negative 6 grams. So this micro symbol, which is a mu, maybe I should make this a little lower or something, mu symbol, that represents a power of 10 of 10 to the negative 6. All right? And then once you know the base unit grams, that's the base unit for mass that we use in chemistry, we need to be able to go from grams to kilograms. So you'll need to know the relationship between kilogram and gram, and kilo means 10 to the third grams. All right? So those two equalities that we show here, I do expect that you have those memorized. And again, the reason why I expect those to be memorized is many times we have to do conversions on the fly, or we don't have time, especially in the lab, to go look up a conversion. If we did that, we'd never get finished with lab in the allotted amount of time. So some of these conversions, it is expected that you could be able to do. All right, so for this problem, again, we want to know how many kilograms is in 5 micrograms. You got to come up with your plan of action. So anytime you're doing a problem, you've got to come up with a plan of action. I don't care if it's a chemistry problem or a problem you're having at home. There's always a plan of action to solve a problem. So the plan of action here, you always work a plan of action from what you know. From what you know personally, that's how you work your problem. So in this case, what we know is we know a relationship between microgram and gram, and we know a relationship between gram and kilogram. So my plan of action is going to be to convert the microgram back to the base unit gram, and then from the base unit gram to our final unit kilogram. So always work the plan of action. That's the hardest part of a problem, but once you get this down, nobody can take that away from you, and it'll work from here on out. Now, some of you, I do hear this from time to time, that you've been taught a cross multiplication or a ratio method. And in fact, that's the way I was taught in high school too. But the problem with the ratio method, it only works if you know the relationship directly from, say, microgram to kilogram. And you could do that. You could say, well, if you combine these two equalities together, you would say 1 microgram is, or let's do it this way, 1 kilogram is 10 to the 9th micrograms. But see, that requires a lot of thinking on your part, and it requires you to memorize even more stuff. So what I propose is that you memorize some of the base units and some of the base powers of 10, and you reuse those over and over, and they will become just like your ABCs. You'll know them from here on out. So that's why my problems, we always start from what's given. We always go through the base unit and then end up at what we're trying to find. It's a little bit longer problem, but this system will work in any chemistry class, any physics class. Once you get this system down, it works all the time. The ratio method, again, it only works if you know the direct relationship. And a lot of times we don't. Many times in science, we don't know what the answer is, and we're using these little steps as a breadcrumb trail to get us from where we know to where we're trying to find out. And so knowing each step, we know the relationship between microgram and gram. That's an identity. And then we have kilogram to gram. That's an identity. And so from those two things, we know for sure we can go from where we are, microgram, to where we're trying to go, kilogram. So let's set up the problem. So we start off with what's given, the 5 micrograms. And from our plan of action, we need to get to gram. So what we know here is that microgram needs to be in the denominator and gram needs to be in the numerator, so that the micrograms will become 1 and we'll be left with grams as our unit. That's what we're trying to do in step number 1 here. So this arrow here represents a conversion problem. So where does a conversion factor come from? Well, it always comes from the equality. So we have an equality here that says 1 microgram is 10 to the negative 6 grams. So if I want microgram in the denominator of my conversion factor, I need to divide both sides of my equality by 1 microgram. This side becomes 1, and that's what we mean by identity. That 10 to the negative 6 divided by 1 microgram equals 1. And you go, what does that do for me? Well, in math, you remember when you have 7 times 1, you get 7. So 1's an identity. It doesn't change the value of the 7. Well, the same thing with this conversion factor. It does not change the amount that you have, 5 micrograms. All it is doing is changing from the unit of microgram to gram. So that's what we're going to put here. 10 to the negative 6 grams in the numerator, 1 microgram in the denominator. So again, when we calculate this out, the micrograms will become 1, and we'll get 5 times 10 to the negative 6. All right. So here is the question, and this is what sparked the interest in creating this video, is how do you put this in on your calculator? How do you multiply 5 micrograms times 10 to the negative 6 grams? Okay. Well, on your calculator, let's see, let me change color so we can see that this is a separate function here. So on your calculator, you're going to touch the number 5. Now I'm going to try this. I don't know if this is going to work or not, and you may not actually see this in the final video, but if I show the calculator here, and it is kind of fuzzy, I don't know if you see this or not, but we're going to assume you do at this point. Okay, so here's the number 5. This is a Texas Instrument TI 83 Plus calculator, and up above the 5 there's a row, and above this row it's a secondary function. It says EE, and that stands for the exponential key. Now to get to these secondary functions, you have to hit a second button up here. So you're going to hit the secondary button and then what looks to be a comma to access the exponential function in on your calculator. All right. So let me talk you through this on the board, and hopefully that'll help. So on your calculator, you hit 5. All right. Next, you hit the multiplication key. Now here's the tricky part. For the next part, the best way to enter this is to hit the number 1, and then on the Texas Instrument calculator, you actually have to hit the second function button, and then you hit a button that looks like a comma, and this all together is equivalent to the exponential key, EE key. That's what you're ultimately trying to get to, the exponential key. Now you say, well, I'm looking on my calculator and I don't see this EE key. Well, if you have a Sharp brand or a Casio brand calculator, you may have a key that looks like this, EXP. That means exponential key. On some calculators, it's not a secondary key. So you don't have to hit the second function and then whatever the key represents, the exponential key. On some calculators, it's a primary key. In fact, the Texas Instrument TI-30 or 30XA has that as the primary key. And if you haven't bought a scientific calculator, I would definitely look at a calculator that has the exponential key as a primary key. All right? So what we've done is we've hit one exponential key, and then what we do is there should be a positive negative key on your calculator, not the addition or subtraction key, but a positive negative key, and that will make this -6 value here, and then you'll put in the 6 here. So just to recap, what we would have here is 5 times 1 exponential key, negative key, 6 key. All right? And you could hit enter here, and you would get for an answer something like 5 times 10 to the -6. Or you could get something like, maybe your calculator says 5e -6. Well, that's what the E stands for. It takes care of all of this part. In fact, it actually ties the exponent to the times 10 power. So you say, well, I've never used the exponential key. I took a math class, and they told us to do it this way. They said to put in the 5 and then say times maybe 1 times, and then hit 10, and then raise that to the -6, and then close parenthesis and do something like that. That's fine. You would get the same answer if you did it this way. You would get 5 times 10 to the -6. The problem with this, I'm an analytical chemist, and we're always looking at problem or error analysis. And so the problem with this is, in order to get this answer correctly, you have to hit one keystroke here, another keystroke here, another one here. You have to put in the number 10, which is usually another keystroke or 2. And then you have to put in -6. That's another couple of keystrokes. And then you got to use a parenthesis key. Whereas if you just say 5 exponential, which may be 2 keystrokes, -6, you have a total of 1, maybe 2 here, 3, 4 keystrokes instead of all of these. And the less keystrokes, the more likely you'll get the correct answer, because you don't introduce error into the system. So the exponential key, really important. I hope you'll use it, and it makes your problems much easier. So just recreating what we had on the other page, we had 5 micrograms. We multiplied that by 10 to the -6 grams. In the numerator is 1 microgram in the denominator. The micrograms have become 1, so now we have 5 exponential -6 grams. Okay, our plan of action was to go from microgram to gram to kilogram. So now what we want is the relationship or the conversion factor that's going to convert grams to kilograms. So we need to know that relationship. Well, we had that on the previous page. We said that 1 kilogram is equal to 10 to the 3rd grams. That's my equality. And from the equality comes a conversion factor. Now, for this conversion factor, we need to divide both sides of the equality by 10 to the 3rd grams. 10 to the 3rd grams. So, and you say, why did you do that? Well, I want the grams in the denominator and the kilograms in the numerator. That's the driving force. This side becomes 1 again, so that tells me this conversion factor is an identity, that it's like multiplying by 1. It doesn't change the amount that I have. All it is doing is changing the units from grams to kilograms. So here I'm going to put 10 to the 3rd grams in the denominator and 1 kilogram in the numerator. So when I look at the problem, I know I've set it up right. This is what tells me, this is my breadcrumb trail to say, hey, I'm on the right track. The grams cancel out here, and I'm left with units of kilograms. So everything looks really good at this point. So it's now just a matter of punching it in the calculator. So again, in the calculator, I'm going to hit 5. I'm going to hit the exponential key, whether it's a primary key or a secondary key. I'm going to say, oops, I messed this up. Oops, let's go back. So I'm going to hit 5. I'm going to hit multiply. There's the multiplication symbol. Then I'm going to hit 1 exponential -6, and all of this takes care of all of that. All right. Then I'm going to hit multiplied, or actually I'm going to hit divide here because this is in the denominator. I'm going to hit divide, and I'm going to say 1 exponential 3. So this 1 exponential 3 takes care of all of that. All right, so let's go through this one more time. I start with what's given, 5 micrograms. I need to change the microgram unit to grams, so that's what this conversion factor does. The micrograms become 1. I have 5 times 1 exponential -6. Then, because this 10 to the third power is in the denominator, I don't hit multiply here. I hit divided by 1 exponential 3. Now you say, well, why didn't you put, where's this one or where's this one? Well, we know anything divided by 1 is 0. I mean 1. Yeah, it's the same number, right? That's what I should say. So that's why I don't worry about this part or this part here. It is in here, but we don't need to go through that on a calculator. All right? So when we do this on the calculator, you're going to get an answer of 5 times 10 to the -9. And then the only unit left standing here is kilograms, so that's my answer. 5 times 10 to the -9 kilograms. And again, that's all we should have is one digit here, not 5.0 or 5.00, because we only had one significant figure in this number here. So there are videos on significant figures in Professor Chemistry. You may want to look over those. Those are really important. They are how we know how many digits to convey in our final answer. But this this particular video is focusing on how to use your calculator to do a conversion problem. Okay? Let's do another one. Let's pick one out of the book so we can just kind of follow it. I think one I would like to do right off the bat is one that was assigned for homework. And let's see. Let's look at problem 1.103. Now, and what I mean by homework, this is a problem that was assigned on the syllabus calendar. And these problems are for your personal journal. If you will do these, and again, the personal journal is really important. In this journal, you should have the problems assigned on the calendar, a glossary of the terms in bold, because you got to speak the language of a chemist, and then also you should have your notes that you've taken while you went through the book. Like there's something you need to ask me about, you can do that, or just to help you refresh your memory before a quiz or an exam. So this is problem 103. This is on page 41 in the Denniston textbook. And again, this is the 8th edition of the General Organic Biological Chemistry book. All right, so looking at problem 103, it says which distance is shorter? 5.0 centimeters. Now notice they got two significant digits here, or 5.0 inches. And I think what throws people about this problem is they think it ought to be really simple, right? It's a real quick question. Which distance is shorter? Well, there's a little bit of a calculation involved here. You have to convert either centimeters to inches or inches to centimeters to compare one measurement to the other. So pick one of these to convert, and so let's just stick with this one. It's up here. Let's stick with this. So if we look at this problem, what we need to do is we need to convert centimeters to inches. In order to do this problem, we have to know the relationship between centimeters and inches. Now, for this one, this is one I think you should probably memorize. It comes up quite frequently. And the equality is there are 2.54 centimeters equals 1 inch. All right? So that's the equality. And you know from the equality, we make the conversion factor. Now, I would agree with this problem. Some of you are saying, why are we going to go through all of this? I can do this as a ratio method because as soon as I know it's 2.54 centimeters to an inch, then I can tell you that I've got about 2 inches. 5 centimeters is 2 inches. All right. That's great. And if you know it like that, you're ahead of the rest of the class. And if you know it confidently, that's fine. That'll work for you on a quiz or a test. Because this, if you know that, I agree. If you know this, you've just answered this question in less than 5 seconds, and you can bank your time on a harder mathematical problem. But for those of you starting out, I recommend that you go through the same process that will, instead of doing a ratio method, go through this factor label method. Because over the long run, these problems in Chapter 1, they're not, the answer is really trivial. I know that's what you're graded on, but it is the process of how to get to the answer. That's what we're looking for. So to get to the correct answer here, we need to convert the centimeters, and we need to convert it to inches. And so from our equality here, we want to divide both sides by 2.54 centimeters. And the reason why we're doing this for such an easy problem is to go through the process, to learn the process step by step of the factor label method. So this side becomes 1. That tells me this side is a true conversion factor. It's not changing the amount I have, it's just changing the unit. So I'm going to put 2.54 here, centimeters, and in the numerator 1 inch. All right, so on the calculator, you would take 5 and you would divide it by 2.54. And you'd get for an answer 1.9685, 1.9685, 1.9865, and the units would be inches. So we were pretty close. It's 2 inches. That's what we kind of said if you knew what you're really doing here. So don't put that as your answer, though. That is your rough answer. Your final answer should convey how precise you made your measurement. This measurement was made to 1/10 of a centimeter. So in multiplication and division, whatever your measurement is, how many digits it is, that's how many digits you can have in your final answer. So you can only have 2. So you go 1, 2. You look at adjacent to the number of significant digits, those 2, and that's an 8. If this number is 5 or greater, don't even look at these numbers. They're gone. So you look only at the 8. So that number is greater than 5. If the number is 5 or greater, you round your last significant digit up by 1. All right, so we would round this up to 2.0. So my answer is 2.0 inches. And again, I know some of you are going, why'd you go through all of this? And I told you right off the bat the answer was 2 inches. Like I said, some of you already know this. It's going to be easy for you. But here's what I want to know. If you know it the easy method, could you explain it just the way I explained it here to someone that doesn't have any idea of what they're doing as far as this conversion goes? Because I hear that a lot. When I ask a student to tell me how they got the answer 2.0 inches, they struggle and they can never clearly tell me that, oh yes, it does come from this equality, and that yes, you are making a conversion factor. And if you can't describe it that way, you really don't know it. And so that's something to be cautious about. Again, the answer is trivial here. It's only in one conversion problem, which, yeah, you could do a ratio method and it would be much faster and quicker. But when we start doing, in Chapter 4, we're going to be doing about 3 of these conversion factors per problem. And it's not going to be just inches. It's going to be moles to grams, and atoms or molecules, and it's stuff where we don't know what the answer should look like at the end. And in that case, you want to be confident that you've got this factor label system down to get to an unknown answer, that you can't just generally look at and go, oh yeah, it should be this answer. And because it's multiple conversion factors, it doesn't lend itself to the ratio method. So that's the difficulty coming, and I'm just trying to these are easier problems, and by the end of the semester, this is going to be such a simple problem. You'll wish you could go back and retake the quiz probably, or redo the homework. So I'm just trying to give you that foundation to work from, so that when we get to the more complex problems, it'll be much easier. So I want to do one more problem, and then we'll wrap this video up. This problem, I think I saw one that, let's see. It was a problem where we have to use a squared unit. That one sometimes throws students. Let's see. All right, this is problem, yes, 97. 97, again, on page 41. And the problem says the typical office has 144 square feet. And so you write down what's given, and the question says calculate that in meters squared. What would that be in square meters? So yeah, in America we would use square feet of office space. If we were in Europe, we'd use square meters of office space. All right, to do this problem, we have to know a relationship between feet and meters. All right, how many feet equals a meter? Now, this is where you could look up this relationship in a book. You could look up feet equals meters. Maybe you know it's 39 inches equals a meter. What I know for sure, though, is just what we did a minute ago. 2.54 centimeters equals 1 inch. All right? And I know for sure that 12 inches equals 1 foot. So I'm tempted to do it this way, because what I've done is I've memorized one length conversion between the metric system and the British units. And so by doing that, I know I can solve this problem. Yeah, it's going to take me more steps, but that's okay. So it's up to you. When we have something like this on a quiz, you've got your journal in front of you. You've got your book in front of you. When you're taking a test, if you have a metric to British unit type conversion, usually I give you some kind of hint there. But for me, just an old standby is to memorize that. Okay, so if this is what I know, and that's what's the key, it is what you know. What you know is how you work a problem out, how you solve it. So for me, I'm going to have to go from feet, in this case square feet, to square inches. And then once I get to square inches, I will go to square centimeters. And then once I go from square centimeters, I'll go to square meters. All right, so it's 3 conversion problems. Is it a big deal? I don't think so. 3 conversion problems. So here we go. We start off with what's given, 144 square feet. Okay, so then I need to know the relationship between a foot and an inch. And we know that 1 foot is, whoops, let's go down here. We know this. 1 foot is 12 inches. So I want feet in the denominator and inches in the numerator. So 1 foot is 12 inches. Okay. Now, we got a problem here. If I just took 144, multiplied it by 12, I would get for an answer foot inches, because this is feet squared. This is only a foot here. So everything that's in this conversion factor has to be squared. That makes sense, right? Because like if you're looking at office space, it's length times width, or maybe it's a side squared if you've got a nice square cubicle. So that's an area. Length times width gives you an area type unit, which is a squared unit. So we have to, and length and or feet and inches, that's just a linear unit. So we do have to square it. And so that's what this parentheses does for me. I'm going to square everything inside the parentheses. All right, let's go to the next conversion factor. We've got to have 3 of them because we see 3 arrows up here. So we're going to go from inches squared to centimeters squared. So what I know is I know that 1 inch is 2.54 centimeters. That's what I know from this equality up here. But again, we need these squared. So I'm going to put all of this in parentheses. And I'm going to square that. And that's going to give me squared inches in the denominator and squared centimeters in the numerator. And then the last unit is I want to get rid of the squared centimeters, and I want to end up with meters squared. And so here is, again, where you have to know the relationship between your metric units. So you should know or have memorized 1 centimeter, centi means 10 to the negative 2 meters. 10 to the negative 2. Centi means 10 to the negative 2. So 1 centimeter in the denominator, 10 to the negative 2 meters in the numerator. So what we effectively did here is took this equality and divided both sides by 1 centimeter. This side becomes 1. That tells me this is an identity. The identity goes in here. It's not changing the amount or the area of this office. It's just changing the unit. And then again, don't forget to square. All right. So we've set up the problem. Now it's just a matter of executing the problem on the calculator. And I'm going to have to erase this up here. Maybe I shouldn't have done it this way. Maybe I should have just gone on to the next slide. But I've already started, so we'll go with it. All right. So we start off with the 144 square feet. And 1 squared is 1, and then feet squared is feet squared. All right, what's 12 squared? So you can put that in your calculator. 12 squared actually comes out to be 144. But this isn't squared feet, it's squared inches. I think it's funny they use the same number. I think to make it a little confusing, because I got the same number here, now you've got it there, but that's okay. That's fine. All right. So then do the same thing for the next conversion factor. 1 squared is 1, so we'd have 1 squared inch. 1 square inch. Now, this one I don't have memorized, so let's punch this in on the calculator. 2.54, and we're going to square that. And we get 6.4516 centimeters squared. You go, do I need all of those digits? Well, you need at least 3 because that relationship was 2.54 and that's got 3. So you need at least 3 there, but we'll carry the other ones. Just we don't want any round off error till the end, so we'll keep that. All right. And then the last one's not too bad. 1 is 1 squared, so we get 1 squared centimeter. And then 10 to the negative 2 squared. Remember, you multiply your exponents, so this is going to be 10 to the negative 4 meters. All right? 10 to the negative 2 times 2, 10 to the negative 4. All right, so we're now ready to get the calculator, punch this out. All right, so how do we do it? We take 144, multiply by 144, and then multiply by 6.4516, and then multiply by, again, how do we do this part in the calculator? It's 1EE, your exponential key, negative 6. Not the subtraction key, but the positive negative key. Looks like this or something like that. And remember, this EE it's a particular key on your calculator. All right? So let me punch that in. 1 second function EE on my calculator, negative 6. Hit enter, and I get for an answer 0.1. Oops, yeah. Okay, let's just do this. Let me show you what happened here. 0.133 2.7 meters squared. All right. Now, here is where somebody knows what they're doing versus somebody that doesn't know what they're doing. Right now, just laughs because they know this isn't the right answer. There's no freaking way that you're staying in an office that's only 0.1 meters squared. All right. Or 0.13 meters squared. So you go, wow, I've made a mistake because there's no way somebody's living in 0.13 meters squared. So you go, well, where did I make the mistake? Well, you know, when I was talking about the exponential, it's not -6 here, it's -4. All right? So let's punch it in again. So we would say 144. Really? My calculator just actually died on me. Can you believe it? I've got another one here to spare. Oh, wow. All right, 144 multiplied by 144 multiplied by 6.4516 and then multiplied by 1 exponential -4. 1 exponential -4. Hit enter. 13.37. And again, you could have just moved the decimal 2 places, but I want to go through the calculation again. So 13.37 meters squared. Now, that sounds reasonable. Remember, meters a little bit larger than a yardstick, so we're talking about maybe something that's what it's still pretty small though, isn't it? 4 by 3 or something like that. That's 12. 4 meters by 3 meters, 9 feet by 12 feet. All right. So is that my final answer? No. Don't write that down as your final answer. This is the measured quantity here, this 144. So you can only report 3 answers in your final answer. 1, 2, 3. And you look at that 7, you go, oh yeah, 5 or greater, I round up. So my final answer to 3 significant figures would be 13.4 meters squared. 13.4 meters squared. All right. So this is a squared unit problem. That's why I chose it. And it is a series of steps. And again, it is a series of steps, and that's what you're trying to learn, is how to take something from one place to another through a series of factual steps, in this case equalities that are used to make conversion factors to come up with an answer. And then when you get to the end of the answer, it is a good idea to evaluate, does that sound like a reasonable answer? And that's what makes you look at that and go, no way. All right, I hope this helps. There are other conversion videos on YouTube on Professor Chemistry. And you can also look at Khan Academy. They also have videos on conversion problems. And that's what I'm here for. If there's something you're stuck on and you can't quite figure it out and the videos that I already have are not helping you, just let me know and I'll make a video. It's no big deal. That's what I'm here for. I love teaching, and I know that online has its pluses and minuses, and so this is the way we try to counterbalance that, is by doing these videos. It'd be nice to do something live, but again, it's hard to meet everybody's schedule online to do live teaching. All right, that's where we'll stop at today, and hopefully